So today we are going to do an aldol condensation between an unknown ketone and an unknown aldehyde. And the ketone we're using is K2. And you can see, I think, in there that is a white solid. And the benzaldehyde we're using is B1, which you can probably see is also a white solid. And the catalyst is sodium hydroxide. We're going to be running this without solvent, so we're actually just going to be mixing these three solids together. So I've started by gathering everything I need. I'm going to do the reaction in 10 milliliter Erlenmeyer flask with a nice wide neck so I can stir easily with a glass stirring rod. I've gotten some pipettes and a chamber for holding them. Gotten out my stirring hot plate because I'll need that for the recrystallization. I've set up a filter with a Hirsch funnel, the number 2 filter adapter, and a 25 milliliter flask and a piece of filter paper, but I haven't started applying vacuum yet. I've got another setup because I'll need a separate setup for the purification. Got a spatula for measuring out my solids, pH paper, and then I've gathered DI water and ethanol because I'm going to be needing to make some 95% ethanol for recrystallization, and the 10% hydrochloric acid that we're going to be using for quench, 2 milliliters of that. And I went and got some ice, so I have an ice bath. So I should have everything that I need, and what we need to do is take our spatula over and measure out our reagents. And I'm going to take my Erlenmeyer flask over directly to the balance. And we want 0.2 grams of the ketone and 0.25 grams of the benzaldehyde. So we will measure those on weighing paper, crease them to make it easy to get the stuff in. Tear that. It really doesn't matter which one we measure first. I'm going to measure the ketone. And we want 0.2 grams. And it's not pure white. It does have a little bit of a cream color to it. That looks pretty close. So we have 0.203 grams of the ketone. Just make a little funnel at the end there. Transfer that. And I'm just going to wipe the spatula on a paper towel. And use the same one to measure the aldehyde. And we want 0.25 grams of this. It looks like it's a little bit of a lower density solid. And that's a little more than required. Came out in one big chunk. Gonna have to break this up a little bit. So that is exactly 0.250 grams of the benzaldehyde. Put those back. And we'll transfer that to our flask. Making sure not to spill that big chunk. And we'll wipe this off. I'm going to leave this here. I'm going to be using that to measure out the sodium hydroxide. And we'll be using 0.05 grams or 50 milligrams of sodium hydroxide powder. So I'll tear that so it's ready. I want to mix these pretty well and grind them up a little bit before I add the sodium hydroxide. So I don't really want those large chunks of kind of what looks like wet solid. And as I mix them, especially if their melting points are close to room temperature, I may find that freezing point depression causes this solution to go somewhat oily. Right, once we mix these, the melting point will be suppressed, and you can see that it's almost going kind of liquidy. So we got a good mixing. No reaction will occur yet because we don't have our base catalyst. But certainly that's now kind of a solution of the two. And now we can go measure out the sodium hydroxide. Open this on top of a trash can because there's often crust around the top. You can see crust around the neck. I don't want to get that all over the balance pan. So 50 milligrams of sodium hydroxide. Maybe a little over, but I don't mind being a little over. A little bit of sodium hydroxide escaped. Put that back too. So we actually have 59 milligrams, 58 milligrams, 0.058 grams of sodium hydroxide, which is a little bit more than is required, but that's fine. We'll bring this over, clean that later. We just want to add this. And we're going to be stirring this for about 15 minutes. It's almost exactly 5 o'clock. So we'll be stirring this till about 5:15. Stick that in there. We're just going to mix that really well. Try to get that sodium hydroxide in intimate contact with the rest of it. You'll see that it's kind of a yellow liquid solution. And I'm trying to break up those chunks of sodium hydroxide to make it as much surface area as possible. Already looks like I'm forming some new solid, and it's only been a couple of minutes. Alright, so this definitely seems to be some product forming. It's a little sticky. You can see it kind of sticking to the steering bar, steering rod. And we just have to patiently keep stirring, try to get good mixing. We've got some yellow, lemony yellow solid. doesn't look like either of the starting material solids. I'm just going to kind of rotate that to try to get as much of the solid off the stirring rod as I can. And keep stirring and mixing. See, the thing's gone almost entirely solid now. We got a lot of chunks attached. So I'm going to want to scrape the walls, try to get that solid. Kind of rotate the stirring rod. It's a little more white than it was now. I'm just trying to scrape that solid out and twist and rotate the stirring rod. It's really one solid mass now. Kind of scrape it down the walls. That's only been maybe 3 minutes. So it really doesn't seem like this reaction is going to require the full 15-minute stirring. I may back that off, especially since there's not that much mixing possible anymore. So scraping down the walls, try to get that stuff off the walls of the flask. I think you can see now that I've got some kind of powdery material down in the bottom. Best to get that stuff off the walls. See, some of it is actually flowing. It's about 5 after 5, so I'm going for about 5 minutes-ish. It's kind of a tan, almost kind of orangey, a little bit of orange tone to it. Mostly our powder. There is sodium hydroxide, of course, trapped within that matrix, which we will be attempting to mix up thoroughly with the hydrochloric acid to neutralize before we do our crude filtration. They're a bit stuck to the stirring rod, which I will eventually have to scrape off. I'm going to reach in with the spatula so that I can get into the edges better and just break up the solid that's stuck around the base of the flask. also use that to scrape the steering rod, get the bulk of the solid off the steering rod. A little different running a reaction without solvent. So there's a lot of powder in there. And I'm just going to try to break the rest of the solid off the steering rod. I have as little solid as possible adhering to the glass surfaces when I add the hydrochloric acid. Break that solid up as much as